Hey Phoebe. Okay, here's the answer to your question. I'm sorry it's taking me so long. Okay, I just made up a new situation, so then you can try to apply it to your situation, but it's like a similar question. Okay, so here's my table of values. Sorry about my curly Y there. It looks like it's in, like that's supposed to be a Y there. Okay, so there's your table of values. I put my X's are going up by 1s, and then my Y values look to be going up by 5s. So the way we check that is we just see, like, you know, from the top one to the one underneath, is it going up or down? It's getting bigger, so it's going up. And we just see, like, how much is it going up from 5 to 10? Oh, it's going up 5. And another way to think about that is you take the bottom one and subtract it from the top one. So 10 take away 5. This one's pretty easy to see that it's going up by 5 every time. The Y's are getting added 5 every time. So those are our first differences. We call them first differences. And if they're all the same, which they are, so if our first differences are the same, then we know our equation is linear. Okay, so that's what we know. So if we're trying to make an equation of this, well, if you think about an equation of a straight line, it's y equals mx plus b is basically the form those are always in, a straight line. Y and x just represent points on the graph, so those are just kind of our variables that we use. And then m and b are these two things that we need to know. So m is our slope, or our rate of change, same thing. And that is equal to the rise over the run. So it's like the steepness of the line. So if you have a line like this, the rise, how much it increases, and the run is how much it kind of goes over. So that measures the steepness. It's like a triangle there. So we're measuring kind of like the hypotenuse of the triangle. So that's our rise and our run. And it turns out no matter where we take the triangle, like even if I took it from these 2 points, it's going to give us the same steepness. So that's what we need. We need the slope. And we also need b, which is the y-intercept. And the y-intercept is the value that y is when x is equal to 0. Because if you had a graph like this, x and y plane, and like you had a line on it, x equals 0 right here. That's your little scale there for your x-axis. And right at 0, this would be your y-intercept. So it's right where your line crosses the y-axis. So those are the two values that we're looking for, m and b. So if we're going to write the equation of this table that I created, we'll need to know the slope, and we'll need to know the y-intercept. So basically that's what the assignment was asking you to find. Can you figure out the slope? Well, the slope is just the rise, which is your, what are your y values going up by? Because that's like your y values in your table. And what are your x values increasing by? So it looks like our rise, so the y values, like the first differences are basically like the rise of our points, and the x values are our run. So it looks like they're going up by 5, so our slope would be 5 over, rise over run. Well, it looks like our x's are just going up by 1 every time. Like they're just increasing by 1 each time. So our slope would be 5 over 1, and 5 divided by 1 is just 5. So our slope is 5. And then our y-intercept is when x is equal to 0. And we can see that right from our table. When x is equal to 0, y is 5. Oh, I made them both the same number. Not ideal, but oh. So we know our slope is 5 and our y-intercept is 5 randomly. They turned out to be the same. So if I wanted to write the equation of that line, I would just write y equals mx plus b. And instead of an m, I'll put that 5. And instead of a b, I'll put this 5. So that would be the equation of this line. So you basically just need two things to write the equation of a line. Okay, so I'll just do one more, just another example. So let's take a look at this guy. So if we want to check our first differences to see if it's a straight line, I can see that they're increasing by, oh, not 8. From 4 to 8, they're going up by 4. So it's increasing by 4 each time. So adding 4 every time. So those are my first differences, and since my first differences are all the same, then I know that this is going to be a straight line. So I want to try to write the equation of it. y equals mx plus b. So if I want to try to find my slope, I need to figure out my rise over my run to find my slope. So I already know my rise is 4 because my y values are going up by 4 each time. And if I wanted to see what my x values are going up by each time, I'll just take a look over here. And from -3 to -1, they're going up 2. From -1 to 1, they're going up 2. From 1 to 3, they're going up 2, up 2. So they're going up 2 every time. And another way to do that would be take the bottom number and subtract it from the top number. So 5 minus 7 is 2, 5 minus 3 is 2, 3 minus 1 is 2, 1 minus -1 is 2. So I can see that my run is 2. So therefore, my slope is 4 divided by 2, which is 2. That's my slope. So if I'm going to write the equation of my line, I would be 2x plus, what would be my y-intercept? This one's trickier because there's no value in x equals 0. We don't know. So this one's a little bit harder to figure out. So like, if you don't want to figure it out, you could write to me, I still need the y-intercept, I don't know it. Or if you wanted to try to figure it out, there's a number of ways you could do that. You could try graphing the line, which is kind of a lot of work, but I mean, it's not like a lot of work. So you could try graphing it and see where it would go through. So like plot the points, so -3, 4, so -3 up 4, -1 and 8. I already know, like I can't fit this 1, 2, 3, 4, 5, 6, 7, 8. So your line's going up like this. So you want to figure out like when is it going to cross the y-axis. Another way to do this would be, since you know your slope is 2, I feel like you could fill in that missing answer. Like from -1, okay, I'm just going to try to demo this. Okay, so from -1 to 1, you know how it's going up by 2? Well, if we just wanted to see like, well, what if we stuck a 0 in there? So now this is just going up 1. I feel like this might be a little confusing, but I'll try. So it's just, we're going to add in like what would be the in-between value and what would be in between 8 and 12. It's like kind of like halfway in between 8 and 12. I'm thinking 10, right? Then it would go up by 2 in there. So I think our y-intercept is going to be 10. So these, like this table follows a really nice pattern. Like the y's are going up by 4s and the x's are going up by 2s. And it's proportional. So if we wanted to make the x's go up by 1s, then the y's would go up by 2s. Like we just kind of cut each side in half, if that makes sense. So that would be the equation of that line. And then in your email, you also wanted to know something about the first differences equation. I wasn't totally sure what you meant by that. So let me know if I've answered it in this video, or if not, I can make you another one. Basically, that should get you through the rate of change assignment, I'm thinking.